Hope you all are doing great. As you all know, we are dealing with chapter 3 of chemistry, that is metals and non-metals. So let's start with our next topic, in which we shall discuss about extraction of metals, which is also known as metallurgy. So let's start with the chapter. So extraction of metals from ores. Getting metal out of its ore is termed as extraction of the metal. The various steps involved in the extraction of metal from its ores, followed by refining of the metal, is known as metallurgy. There are three major steps involved in the extraction of any metal, which are enrichment of ores, extraction of metals, and refining of metals. So let's start with it. So first step is enrichment of the ore, which is also called as the concentration of the ore. Ores are mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, dust, stone, etc., which is known as gangue. The first step in the metallurgy, children, is to remove these unwanted impurities from the ore such that the concentration of metal in the ore increases. That is, ore is enriched in the metal. This is called as enrichment of ore. There are various methods of enriching the ore which is not there in the syllabus in class 10. This we will be discussing in your higher classes. So second step in metallurgy is extraction of metal from the concentrated ore. The method used for the extraction of metal from the concentrated ore depends on the nature of the metal. Metals have been classified into the three categories on the basis of their reactivities that we have already discussed in your previous class. Number 1, metals of low reactivity, metals of medium reactivity, and metals of high reactivity, which are present at the top of the reactivity or the activity series. So children, with the help of this flow chart, please try to understand how we go about for the extraction of different metals from different ores after we get the concentrated ore from the first step of metallurgy. So here basically we are going to elaborate and understand the second step of metallurgy, that is extraction of metal from the concentrated ore. So children, it's very clear from this diagram. See, when we talk about the metals of high reactivity series, then we just have to do the electrolysis of the molten ore and we are going to get the pure metal. Now come to the right hand side of the flow chart where the metals of low reactivity series are there. For such metals, if the ore is sulfide ore, then we'll do the roasting of the sulfide ore and we'll be getting the metal, and that impure metal will be refining the metal to get the pure metal out of it. Now children, in the middle part of the flow chart, that is if metals are belonging to the medium reactivity series. In such a case, we can have three types of ores present: oxide ore, carbonate ore, and sulfide ore. If the ore is oxide ore, then we have to reduce the metal. This means reduction of the metal is to be done, and then after refining of the metal we will get the pure metal. If the ore is carbonate ore, then we have to do the calcination for it. After doing calcination, we are going to get the oxide of the metal. Again, the reduction of the metal will be done, and at the last we have to do the refining of metal to get the pure metal. Now the third case, children, if we have the ore in the sulfide form, that is sulfide ore, then instead of doing calcination, we are going to do roasting, and after roasting, again the same step, we are going to get the oxide of metal. Then after reduction we are going to get the metal, and after refining we are going to get the pure metal. So this way you have to understand that which kind of ore is to be dealt with, which kind of methods for getting the impure metal out of it before the refining takes place. Now I'll be making you understand the various terms that are used in this flow chart. So first of all, let's discuss what is roasting. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is called as roasting. So children, roasting is the process of heating the ore strongly in the presence of excess of air, and ore has to be the sulfide ore. As a result, the sulfide ore is converted into metal oxide. For example, we have zinc sulfide here, which is also known as zinc blende, which is the sulfur or the sulfide ore of zinc. When we are going to heat this zinc blend in the excess of oxygen, then we are going to get zinc oxide, and sulfur dioxide gas is removed out of this process. So here children, after roasting the zinc sulfide, we are getting zinc oxide. So now the next term was calcination. The carbonate ores are changed into oxides by heating strongly in the limited air. This process is called as calcination. Children, the main important thing that you have to understand here is roasting is done in the presence of excess of air, and calcination is done in the presence of limited air. So we say calcination is the process of heating the ore, that is carbonate ore, strongly in the absence or in the limited air. Thus, the metal carbonate decomposes to give metal oxide. For example, here children, we have taken zinc carbonate, which is calamine, which is the ore of carbonate ore of zinc. And if we are going to heat it in the absence of air, then we are going to get the oxide of zinc, that is zinc oxide, and carbon dioxide is liberated in this process. So children, here after doing calcination also the end product is same, that is we are going to get the oxide of the metal. In both the processes, in calcination and after doing roasting, we have got the oxide of the metal ore. Now the oxide ore has to undergo reduction. What is reduction? Metal oxides are reduced to corresponding metals by using reducing agents. Since these metals are moderately reactive, their oxides cannot be reduced by heating alone. Thus, their oxides are reduced to metals by using suitable reducing agent, such as carbon, or sometimes highly reactive metals like sodium, aluminium, etc. are also used for doing reduction. For today, children, I hope whatever was explained in today's class, you must have understood it nicely. If you have any doubts, you may ask any number of times. God bless you all.